Hi again, physics. Here we are, momentum problems number 5. This is problem number 2. So Alice and Billy are sledding together on a frictionless surface at 6.91 meters per second. The combined mass of Alice, Billy, and the sled is 138 kilograms. Billy, whose mass is 65.5 kilograms, says something obnoxious, so Alice tosses him forwards out of the sled with a velocity of 9.25 meters per second relative to the ground. What is the final velocity of Alice and the sled? So as always, start off step What are we looking for, and what units do we expect it to have? So what is the final velocity of Alice and the sled? So we're going to call that V sub A final. So that is equal to question mark, and it's a velocity, so it's going to have units of meters per second. So on to step 1, make your sketch. But again, it's a conservation problem, so there's going to be 2 sketches. There's going to be an initial sketch and a final sketch. So what's happening in our initial sketch? We have a sled. Let's see. We have Billy. We'll have Alice standing on the sled too. Seems a little bit dangerous. But they're on the sled. They're going to the right. At the start of this problem, our masses are stuck together. Billy and Alice and the sled are all one giant mass. So I'm going to say mass of Billy. I guess that should be capitalized. Okay, mass of Billy plus mass of Alice. This is equal to the combined mass is 138 kilograms. The initial velocity of all these guys, well, there's only one initial velocity, so I can just call it V sub I, is 6.91 meters per second. So that's what we need from the initial picture. In the final picture, what have we got going on? So Billy said something foolish. So Alice ends up throwing Billy out of the sled. And she's throwing him forwards out of the sled. So here's Alice. She has thrown Billy. So here's Billy. Alice is still moving. And we need to figure out what's going on here. So if the combined mass of Alice, Billy, and the sled is 138 kilograms, and Billy's mass is 65.5 kilograms. Well, the mass of Alice and the sled together, which I'm just going to call mass of Alice, because they're still stuck together and they're still moving together, is going to be 72.5 kilograms. Velocity of Alice final is going to be question mark, meters per second. That's what we're actually looking for. And now, what's going on with Billy? So we have mass of Billy. Mass of Billy is 65.5 kilograms. And velocity of Billy final is equal to 9.25. Sorry, that's a 5 meters per second. So that's what we need out of our sketches. On to step 2, the conservation of momentum. So we have sigma P initial with a hat plus J external. Any external impulse we have with a hat is equal to sigma P final with a hat. So the sum of our final momentums. So as usual in these problems, the problems I'm giving you, there's usually not going to be any external impulse. That's just going to be 0. We've got nothing from outside of this system adding or subtracting momentum from us, so that's just going to be 0. So initially, where do we have momentum? Billy and Alice are all stuck together, so I'm going to call that P B plus A initial. so that's their initial momentum, plus 0 external impulse, is equal to sigma p final, some of our final momentums. Notice in the final picture, we've got momentum in two different places. We've got a momentum of Alice, final, with a hat, plus a momentum of Billy, final, also with a hat. So again, when you're doing these problems, you should have an initial sketch and a final sketch. The initial sketch should match the left side of your equal sign in the law of the conservation of momentum, and your final sketch should match the right side. So initially, I've got this, that matches this picture. Finally, I have this and this, so that matches this picture. That's Alice's final momentum and Billy's final momentum. So step 3, we're doing math. So first part of math, take off the hats, put in the signs. So momentum of Billy and Alice initial. Look at your initial sketch. Everything's moving to the right, so this gets a plus. So PB plus A initial is equal to P Alice final. At the end, I'm guessing Alice is going to the right. We don't actually know that for sure, but I'm guessing she's going to the right. So I'm giving that a plus. P Alice final plus Billy is definitely going to the right, because it says in the problem that Alice throws him forwards out of the sled. So P B final. So we've got this. At this point, I'm going to sub in MVs for all of my P's, and I'm going to be careful to use all of the subscripts that I need. So the first one, P, B plus A initial. These guys are initially stuck together, so mass of Billy plus mass of Alice times the velocity initial of those guys. And then on the right side, P of Alice final. So that's going to be mass of Alice, V of Alice final, plus PB final is going to be mass of Billy times the velocity of Billy final. So in this problem, we have things that are stuck together at the beginning, and they are separate at the end. So this type of problem is what we call an explosion. Whenever you have your parentheses on the left side, you have one big mass in the initial sketch, and you have separate masses at the final sketch. That's what we call an explosion in physics. So if I look at this, the thing I'm actually trying to solve for, velocity of Alice final. So that's this one. So I've got to do some algebra to get that thing by itself. So first thing I'm going to do is subtract MB, VB final from both sides. And on the left, that's going to give me mass of Billy plus mass of Alice, velocity initial, minus mass of Billy, velocity of Billy final. And all this equals mass of Alice, velocity of Alice final. So the thing I need to do is get the VA final by itself. So I'm going to divide everything by mass of Alice. So the left side divided by mass of Alice, the right side divided by mass of Alice. So these guys go away. So on the right, I just have velocity of Alice final. So I'm actually going to switch left and right to make this a little bit easier for me to do. And then I'm going to plug in the numbers because I'm running out of room here. So velocity of Alice final is equal to mass of Billy plus mass of Alice. That is 138.0 kilograms times their initial velocity, 6.91 meters per second, minus mass of Billy times velocity of Billy final. So mass of Billy, 72.5 kilograms, times the velocity of Billy final, 9.25 meters per second. And all of this divided by the mass of Alice. And the mass of Alice, sorry, I got the mass of Billy wrong. Let me fix that. Just realized I subbed in the wrong mass there. Okay, so minus M, B, VB final. So I copied the wrong number. Mass of Billy. That's 65.5 kilograms times the velocity of Billy final, 9.25 meters per second. And all of this is divided by the mass of Alice. So that is the 72.5 kilograms. Hard to write with one of these pens. So if you do all of that in the calculator, and you get the order of operations correctly, let me give you a little hint. One way to do this is put another big set of parentheses around this. You want to make sure that you're doing the whole top, getting a number, and then dividing that number by the bottom. So you can do that by adding another set of parentheses. If you do that, and you get it correct, the number you're going to end up with, 4.80 meters per second. And we're going to put a box around it. And now we have to see, does this make sense? Well, first, we did solve for velocity of Alice final. It has units of meters per second, so that's good. 4.8 meters per second, that's about 5 meters per second, which Bloody Cheetah is about 10 miles an hour. So that's a reasonable speed for a person on a sled to have. And then finally, let's think of this number. At the beginning, everyone was moving 6.91 meters per second. So all of the masses were together, and they all had that velocity. At the end, some of that mass, the mass of Billy, ends up with this higher velocity. So basically, they were together, they had one big amount of momentum. At the end, they're separate. And Alice has given some of the momentum away to Billy, which means we end up with a number, 4.80 meters per second, that was smaller than our initial velocity. Hopefully that makes a little bit of intuitive sense the way that worked out. If you were sledding and you're going forward and you threw something out of the sled forward, you would kind of recoil and lose some of your forwards momentum, and you'd end up going slower. So that's why we got a smaller number. Hopefully that makes sense. And once again, this kind of problem is what we call an explosion, because we started with all of the mass together, joined with parentheses. Everything was stuck together with parentheses at the beginning, and then at the end, our masses were separate. So when you start out with masses together at the beginning and masses separate at the end, in physics we call that an explosion. So hopefully that was helpful.